the architecture in Snowflake. This really helps us to understand the concept of Snowflake, and also it makes it a bit easier for us to work in Snowflake if we have understood those underlying concepts. So we need to talk about the 3 different layers of Snowflake. So this is something that is very important, and we can see them here. And this is basically what Snowflake consists of. So first of all, we have here this storage layer. This is the layer where we store the actual data. So we know, or maybe we don't know yet, that the data is not actually stored in Snowflake itself, but we use an external cloud provider depending on what we are selecting when we set up our account. So we have selected as external cloud provider AWS. So therefore, for the storage, we use AWS S3 buckets. This is all done under the hood. We don't have anything to do with it, so we don't need to maintain this, but this is just done under the hood for us, where the actual data is saved. And here the data is also stored in a so-called hybrid columnar storage. So this means that instead of saving the data in rows, how it is done in many of the traditional transactional databases, it is actually stored in columns, and it is also compressed into so-called blobs. So this is how the data is stored in the cloud providers. And then when we query the data, so we want to get the data back out and we want to see it, we then fetch also those blobs instead of those rows. And this type of storage is used in many big data contexts, and it doesn't only make it more efficient in storing the data because we can compress it very efficiently, but we can also have a better performance in our analytical database. So we are using this for an analytical database. So we want to have a high performance in getting the data out of the database. And this is what this is optimized for. So therefore, we have this storage layer, and you see we have a separate layer, which is then the so-called query processing layer, or for short, sometimes also just the processing layer. And this is also sometimes called the muscle of the system, because this provides the actual compute power to execute the queries. So this is the layer where the queries are processed, and this is where the very important so-called warehouses come into play. So they are not to be confused with actual warehouses or data warehouses in the context of ETL processes, but they are just basically virtual compute resources that are used to process the queries and all of the operations that we are executing. So therefore, we call this layer the muscle of the system. And these warehouses, they can also perform massive parallel processing, which makes them more efficient in this case for handling large amounts of data or very compute intensive or complex queries. And we can, like this, also combine multiple queries and process them all in the same time. So this is the layer where we get the compute capacity for the execution of the queries. And then on top of this, this needs to be all orchestrated, and this is done in the so-called cloud services layer, or sometimes this is also called, therefore, the brain of the system. So this is what we use, or this is the layer where we manage the infrastructure, all of the access control. So basically, all of the things come together here. Also security, metadata, query optimization. This is also all done in this cloud service layer. All right, so this is the 3 layers of Snowflake. And now we also want to talk a little bit more in detail about the warehouses, because those warehouses, as we have said, they provide the compute capacity. And basically, they are just virtual compute instances or servers that are used to process the queries, because we need to have compute power. And they do come in different sizes, as we can see in here. The smallest size is extra small, which just consists of 1 single server. And if our queries are not very complex, then we can use the smaller size. And if the queries get more complex, it would be more beneficial to have faster queries, of course. And to get those faster queries in those more complex queries, we would have to have higher amounts of servers. So we basically have larger warehouses. So for example, we have a warehouse of the size S. This consists of 2 servers or 2 virtual compute instances, and therefore it is more powerful. So when we don't want to wait very long and we have more complex queries, it makes sense to then use a larger size of our warehouse. So you can see here, each size always increases the number of servers, and it always doubles them up to 4XL, which consists of 128 servers. So here, of course, large warehouses are then also more expensive. For example, an extra small warehouse consumes 1 credit per hour when it is active. This is exactly how we are built. So we are built based on the time a warehouse is active. And of course, one server in this case, so XS, is consuming 1 credit per hour. And this is built by seconds. So here, if we just run it for half an hour, it would be, for example, half a credit. And of course, here, then when it's getting larger, so for example, L, this is then consuming 8 credits per hour. And in this case, we would then pay for the credits. So we convert basically the euros or dollars into credits, and then we consume the credits and pay by dollars. So this is all done automatically. We have just this consumption basically of our credits, and it also depends on the external cloud provider that we are using and the region that we are using and the edition that we are using, what the actual price for the credits is. But here we see always 2 credits, for example, for the warehouse S for 1 hour. So this is how it works. And then we also have the multi-clustering. So Snowflake offers this multi-clustering. This means that if one warehouse, for example, of the size S, can't handle the query load, additional clusters can be activated and they can be clustered together into one warehouse or one cluster of warehouses. And then we just have here basically 6 servers, and this can be now depending on the workload, so depending on the number of queries, which makes it more dynamic. So if there are too many queries for one warehouse to handle, then they just get queued, the queries, the additional ones, and this would cause delays. So therefore, we have now those additional warehouses that are then added. So here we have more compute power to process this simultaneously. So like this, we can make this just more efficient. All right, so this was a high-level overview over the architecture, and I hope that this helps in the understanding, and also it will help when we are working with Snowflake practically in the next lecture. So now let's dive a little bit deeper into creating the warehouses using secure commands and also the Snowflake interface. Hope